Hello everyone. I am Raja Rajeshwari from SNS College of Technology in the Department of Artificial Intelligence and Machine Learning. So in my last lecture video we have seen about the machine learning process, and the thing we have to recall is supervised, unsupervised and reinforcement learning we have seen in last class itself. And the thing we are going to see in this lecture video is to understand the complete machine learning process and their preliminaries and terminologies. So the overview of machine learning process is for data collection, data cleaning, future engineering, model training, evaluation, deployment. So in data collections and cleaning, model training that are not seen in last class itself. So what is data collection? In the sense is to collecting the data from the databases which have the sensors and some online webs logs, and which have the primary and secondary data, which is have the data quality and quantity which impact model accuracy. So the main thing is to collecting the data from the databases. And the next thing is data pre-processing, which is mainly used for cleansing the collected data to handling the missing values. So this is for mainly data reduction and data transformations and data splitting, which is mainly for splitting. Means we have to split the large number of data into testing data and training data. So 80% of training data we are going to implement the 20% of testing data. So these and all comes under data pre-processing. And the next thing is model training. We have to select the suitable machine learning algorithm to train the model by using the optimizations, and model learns patterns which have some patterns to follow the trained model in the model training. And model evaluation is using the test data for evaluations. The basic thing in model evaluations we have seen in last class itself. So today we are going to see about the brief explanation of evaluations, which has the mean squared error, root mean squared error, mean absolute error and R squared error. So in this process we have the regression metrics, common regression metrics. Regressions in the sense it comes under supervised learning, that is classification regression. So under regressions we have the linear and logistics. So linear regressions is the line graph which has the formula, which has the line formula of y is equal to mx plus b, which has the linear regression metrics. And in logistic regressions we have the sigmoid functions to follow the some metrics to be followed in sigmoid functions. So under logistic regressions we have the overfitting, underfitting, bias, variance that all comes under the regressions. So if we have the high bias, means it's considered as an overfitting. If you have the low bias, means it's considered as an underfitting. So underfitting and overfitting is for least square, which is mainly for finding the difference between actual and predicted value, which is called the least squares. So in the mean squared error we have to find the loss of the least squares, that is the loss is equal to mean squared error plus wi, which is summation of wi is weightage of the least squares. And the main thing is for finding the difference between the actual and predicted value. So root mean squared error and mean absolute error and R squared is the main thing, main steps we have to follow in the ridge. Ridge means under regressions we have lasso and ridge regularizations. So regularization in the sense it must be reduces the unnecessary data, which is if we collected the data we have in the databases, it will consider as a zero weightage for unnecessary data. For example, it is considered as a lasso. For example, we will consider as a package, luggage bag. That is, if we packed some necessary things for any trip, means it will, if we have packed the only necessary items, so this is considered as a lasso regressions, which is L1 regressions. And if we not considered it as an unnecessary things, so only we will pack the necessary items only, so it will called as a lasso regressions. So in rich regressions, it will lasso regressions, it will neglect the unnecessary items which have gives the weightage as zero. In rich regressions, it will have the house price reductions. So these are the model evaluation process in the machine learning. So next process we will see in next class. Thank you.